In this video, we'll be investigating the derivative function. This is section 2.4. We'll be estimating the tangent line slopes at various points on a curve. We will look at what the slope tells us about a function, and we will sketch a slope curve, which is the graph of the derivative. So taking a look at our notes, here we have a graph of the function f of x. It appears in this limited window to look like a cubic function, a positive cubic function, so it's going up and then down and then up. What we'd like to do is draw tangent lines to the curve at various points and just get an idea of what the slope of each tangent line is. So here you can see that they are indicating that the slope of the tangent line to the curve at the point -1 appears to be about +2. Okay? So they've just drawn a tangent line and used that tangent line in the grid to estimate the slope. I have two other tangent lines drawn on this graph. The tangent line at the peak and the tangent line at the valley. And looking at those lines, they look horizontal, which means the slope would be 0. Okay, if we put a few other tangent lines on this curve, let's see, I'm going to put one here to the left of -1. And let me make it a line. So if I put this tangent line here, we might estimate that this tangent line has a slope steeper than 2, right? Maybe this has a slope of 4 or 5. Let's say 5. Again, I'm just estimating, nothing too specific. Okay, if we come here, maybe at +2, okay, I didn't use my line function, but let me try that. All right. We might estimate that the slope here is negative. And I don't know, I think it's maybe like a -2. So I'm just going to put a -2 here. All right, coming up the curve a little bit, let's go closer to maybe 1/2 or even close to 0. If we look at the tangent line at this location, let's see if I can get that. Okay, that's a little better. To me, that looks like maybe the slope is -1. All right, so we have -1. We're getting steeper somewhere in here. When I come down here closer to 3, right, maybe that's closer to 1/2 or something. Could be -1, right? But somewhere closer to this 0 line slope, we might have 1/2. Okay, so taking a look, my numbers are for slope 5, 2, 0, -1, -2, -1, 0, and then we're getting positive again in this region. I'll just put it at +1. Okay, so let's take a look at our table. All right, so this is interval notation, so we're talking about x on the interval from x equals -2 to -0.5. So -2 to -0.5. Here's our first interval. What are the slopes doing? Are they positive or negative? They are positive 5, then 4, then 3, then 2, then a half, then we get to 0. So they are positive on this interval. And are the slopes increasing or decreasing? Well, we're going from 5 to 2 to 0. So we're going to say these slopes are decreasing. Okay, they are smaller, getting smaller, but still positive. Okay, all right, the next interval between 0.5 and 1.5. Okay, in here. So we're kind of like breaking the graph right here. So let's think about a few more slopes in that region. We might have 0 slope, then a negative 1/2, then negative 1, then negative 2, and maybe even in here it becomes a negative 3. So it's getting steeper, right? So getting steeper negatively. Okay, so what are the slopes doing between negative 0.5 and a half? They are negative. And are those slopes increasing or decreasing? Okay, if you go from 0 to negative 1/2 to negative 1 to negative 2 to negative 3, your slopes are decreasing. All right, they are getting more negative. Okay, you could say they're getting larger negative, right? You have larger negative numbers. All right, let's look between 1.5 and 3.5. Right, so roughly where that 0 is happening. Okay, the slopes are negative. We're going from negative 3 to negative 2 to negative 1 to maybe negative 1/2 to negative 1/4. Okay, slopes are still negative, but when you go from negative 3 to negative 2 to negative 1 to 0, your slopes are increasing. Okay, they're getting less negative. All right, beyond 3.5 to 5, looks like my graph was cut off a bit, but out to 5, the slopes are now positive. And we're going from 0 to maybe 1/4 to 1/2 to 1, to, if the graph continues, right? Depending on what it's doing, those slopes are increasing. And we are getting larger positive numbers. Okay, so I've kind of drawn these tangents over on this first graph, right? And let's complete a table of values. So I'm going to take a look at negative 2 on this graph. I don't know, I said it was 5. At negative 1, well, they told us it was 2. The slope was 2. At 0, the slope might be negative 1/2. At positive 1, maybe the slope's negative 2. At 2, maybe the slope is at negative 2. Now I'm going to say that maybe in here at 1.5, the slope might be negative 3. Okay, at 3, I don't know, we could estimate a negative 1. At 4, oh, and let's put in here, at 3.5, we're going to get a slope of 0. And I'm also going to put in here at negative 0.5, we got a slope of 0. All right, at 4, maybe 1/2, and at 5, 1. Okay, so these values represent the slopes. This is the slope of the function at those particular points. What we'd like to do now is sketch the graph of the derivative In other words, we want to sketch the coordinates x, f prime of x. So it's just like looking at this table and plotting these points. So if at 2 we're up, -2 we're up at 5. Right? If at -1 we're up at 2. At 0.5 we're at 0. I actually like to put those points, the 0 slopes, on the graph first as anchors. Okay, at 0 you might be at -0.5. 1 you're at -2. 1.5 you're at -3. Back at -2, -1. Let's see, 4 we're at half, 5 we're at 1. Those numbers are probably not really very accurate, but this is a cubic function, okay? And when we draw this derivative, I'm not hitting these points very well, but when we draw this derivative, we get some kind of graph that looks like it's a quadratic graph. Now, your initial graphs for drawing these derivatives, they won't be accurate or very pretty, but you'll learn some patterns to figure that out as we go along. So this would be the graph of my derivative function. Okay, based on the graph of f of x and its derivative, answer these questions. So I'm just going to put a rough sketch of this derivative again on my graph. I'm not going to really worry exactly about where it is, but I'm going to call this f prime of x. I do know it has 0 slopes at these two places. All right, when is the derivative function, when is the blue graph positive? Okay, well, it's positive for x from -5 to -0.5. And also from 3.5 to 5. We'll just say we're stopping our intervals from, oh, I'm sorry, that should be, let me fix that, -2, right? So just looking at our graph from -2 to -0.5 and from 3.5 to 5. When is the derivative function, when is the blue graph negative? Oh wait, let me come back. I didn't answer the question. When the derivative function is positive, so on these intervals, the graph of f of x is what? So they're saying when the graph of the derivative is positive, which is here and here, what is my function doing? So here's my function. That piece and that piece. So what is my function doing when the derivative is positive? Well, it looks like my curve, the yellow highlight, right, f of x has a positive slope, right? So f of x is increasing. Okay? All right. I'm going to erase that yellow there for a second. Okay, so f of x is increasing. Okay, when the derivative function is negative, so that's between -0.5 and 3.5, what is my function doing? Okay, so here the blue graph is below the x-axis, which means the slope of the function is negative. If the slope of the function is negative, the function is decreasing. Okay, we'll pick up in the next video.